All right. So I'm back. Should we start now? All right, great. Let's start now. So, all right. So we have discussed a couple of things so far. We have discussed the general architecture of Yarn again and various components. Also, we had discussed about the standalone mode and how to download and run it. Now, the main important part is so we discussed about this part, standalone part, and then we talked about various entry points, or you can say command lines, or the binaries, or the programs which help us run various programs. Okay. Now, when we talk about non-standalone mode, as in to run on top of Yarn, okay, when you have to run on top of Yarn, okay, we'll not cover Mesos installation on Mesos. We'll cover installation on Yarn, and that's pretty straightforward. Okay, just the important part you need to understand is the client and the cluster. All right, so Yarn can run in two modes, and probably you would ask that as a question. So in this diagram, you would ask that does the driver node run on where does the driver application run? Does it run on does it run on job tracker or task tracker? Okay, that would have been your question. If you think about running all of this, okay, on a Hadoop cluster, okay, you will ask me uh, where will driver application run. This is understood that Spark applications will run on each individual task trackers or node managers in case of Yarn. So while Spark application is running on the node manager as in the individual node, where does the driver application run on Yarn? Okay. So if you remember, in Hadoop 1.0, we used to call something called job tracker and task tracker. In the Hadoop 2.0, which is Yarn, the same thing became resource manager. The job tracker became resource manager and task tracker became the node manager. Inside node manager, there is something called application master. All right. So application master is where the Spark applications run, and the application master or task tracker, you can say, they run on each individual node. Okay, so therefore, the Spark application is running on each individual node inside the application master. That is very straightforward. Now, question always remains, where will my driver application run? Driver application is the one to which we have given our program and it's executing step by step, step by step. If it realizes that this step needs to be sent to the Spark application, it sends it there, get the work done, collect the data, and run the next phase. Okay, so driver application is basically the driver of the whole application, right? So now the question always remains. So what do you think? If we are running our Spark application on top of Yarn, where should driver application run? On the resource manager or on the node manager? Or you can tell me in terms of Hadoop 1.0 as well, on the task tracker or on the job tracker. Anyone? Gaurav says resource manager. Anybody else? Okay. Iswar also thinks that it runs on the job tracker. Job tracker and resource manager are the same thing right now. Let's not get into 1.0, 2.0. Okay. All right. So anybody else? So where do you think should driver application run? Is the question clear, or should I repeat? So in case of Hadoop, you have job tracker. Okay, let me just note it down. So there is something called job tracker, and which is similar to sort of resource manager. Okay, and then there is something called task tracker, which became which became something like node manager inside, and node manager plus application master. Okay, the question is where does the driver application run? All right, all right, good. So the answer is little political. Okay, answer is little political, in the sense that it can run as both. Okay, the okay, so where does the driver run? So if you run it on external node, not on the application master or node manager, then the we call it the yarn client. Otherwise, we can also run it inside the cluster. Okay, the way when we were running in the local mode, the argument to option called dash dash master we provided as local, here we'll provide as yarn client, and here we'll provide as yarn cluster. The diagram will make it clear. Okay, so now you can have a look at it here. Okay, so there is there is an existing yarn cluster. In a yarn cluster, what you have: node manager, which is equivalent to task tracker, node manager again, second one, third one, fourth one. So four task trackers or four node managers are there. One resource manager is there. Now let's not talk about RDD for some time. Now, when our driver application is running on some machine and is asking resource manager to get its work done on each node manager, okay, this is called yarn client mode. Okay, this is called yarn client mode. All right, so basically the driver application from where we are launching anything, or the way we have our, what you call, the place where we are running our program, and that program is being delegated to Spark application. It's running at not on resource manager, not on node manager. It's running on the node from where you're launching the program. Okay, wherever you're launching the program from, wherever you're executing Spark, wherever you are executing Spark Submit, wherever you're executing Spark Submit, the driver application is running on the same node. This is called yarn client mode. And do you see any downside of this approach? Also, on each node manager, there is a shell. There is shell, as in there is a envelope, or there is a environment in which we are running application master. Okay, so we are running application master inside the node manager, and this is where the Spark application lies. Okay, now this is one node. The- so inside app master, if you remember when we had a discussion about yarn, so for each new kind of application, there is an app master. If we are executing MapReduce on our yarn cluster, there will be another app master dedicated to MapReduce. Here there is a Spark application master that is dedicated to us. All right, so right now our individual applications are running on the individual node managers, manipulating RDD, as in transforming the RDD from one to another, and giving results back to driver application. This gives results back to the driver application. In case at any point of time there is a disconnectivity between driver application and the resource manager, or there is a problem with if this process of driver application is killed, the whole process would stop. There will be a signal sent to the application that please shut it down because driver application is not available. All right. So so Mehdi's question is, this question is going to be on the exam. Don't worry about the exam. Let's focus about the concept, because again and again you will keep coming with this point that should we run it in the client mode or the cluster mode. Okay. Now there is a question from Ishwar. Good question. Can we have multiple driver application? Can we have multiple driver application? Yes. So you execute something that's your driver application. I'm executing here something that's my driver application. On a server, there could be multiple driver application, and the problem is resolved by using queues. Okay. So inside Yarn, you can define multiple queues so that multiple people can execute things parallelly instead of waiting for others to finish. Okay, and you can mention the name of the queue while launching anything on Spark. All right. Now the other mode, this is clear to everyone. Should I move to the next mode? No. Hi. So again, because of the power outages, the networks are, I mean, hi. So are you able to hear me now? I was completely disconnected. Okay, okay. So yeah. All right. All right. So all right. Now coming back to the question that so there is one mode where we run the driver application on the machine where from the job is being launched. This is called yarn client mode. Now, okay. Now let's have a trial run before. So for our this is our first entry point, or you can say the first time things on we are trying to run things on Hadoop cluster. Okay, using the or let me log in from here. I can say, all right, I can say student Hadoop. Okay, I think it should run from any login. Now, the important part to see is while we are trying to execute things while we are trying to execute things inside the inside Hadoop cluster, either we have to tell Spark about our cluster, okay, either in the form of yarn underscore conf directory or in the form of Hadoop conf directory. So this is where our Hadoop config is generally stored. I can show you that. So this is where our Hadoop config is generally stored. You can have a look at the the configuration of various things. Okay. So like you can see HDFS site has all the configuration. Okay. HDFS site has all the configuration of HDFS. Okay, you can see that. All right. So all we need to tell Spark is that where is our config directory. Okay. So once we inform Spark about our config directory, let's just put in the both the variable. It doesn't matter, and then we can execute our program with mentioning that we are trying to execute our program as yarn client. We'll say spark submit. Okay, this is the command which runs our classes on Spark, and there we say please execute this particular class. All right, and we mention here how many executor do we want, how much driver memory we want to give it, how much executor memory we want to give it, and how many cores do we have on each machine. Okay, and then the full list of jars which contain our class. You see that? And then this is the argument that is going to your program. So this is your program. This is the program which you wrote. Okay, and after you have compiled it and bundled it in the jar, you are trying to execute it now. Okay, you are trying to execute it now by using Spark Submit. Okay, this is non-interactive way of getting things done. It's submitting the job onto Spark. Let's try to execute it. All right, so we are here. We were, yeah, okay. Now it has started working. All right. In the meantime, if you want, you can have a look at the UI. This is the Spark API. At the same time, it's basically showing you the the work that is being executed. Okay, let it get refreshed. All right, this is the full environment. Okay, so here you can see the logs of your job. You can see there is a Spark submit happening. Let it refresh. Yeah. Okay, so you can see that. So it says what has it done? So did it finish? Let me have a look. So nothing has happened much. Let's try to go to our Hadoop's cluster generally runs on 8080 port. I mean the logs basically. We can have a look. So this is what we just executed. So you can see that we are inside yarn, and in the yarn we can see our job. That means our work was actually executed. Our Spark program was actually executed on yarn cluster. You can see that. Okay, and here it's being executed only one node right now. Okay, so it says that, did it succeed? Yeah, it says it succeeded. Then where is my answer? It must be here on the screen. It must be on the screen. All right. If we just reduce the log level, it will be better. We can reduce that. Do you see somewhere the pi value of is this much? Okay, where is my output? Yeah, you can see that. The pi is roughly this much. That's what is in the output. 8088. You can see. Alright. So we were able to see that it has computed our pi by using our Hadoop cluster. Alright. Alright. You can see all the things that are being executed. Alright. On the cluster. Alright, great. Now going back to the where we were. Alright, good. Alright, so this is clear to everyone. So we ran it in the client mode. So the answer came onto the screen, right? Answer came onto the screen. It did not go somewhere, right? Now that's a difference. So answer came onto the screen and it did not go into the logs. Now it's the same thing if we try to execute in the another way. This is the yarn mode. Okay. In this, what's happening is we have put the driver application also on one node. So our launcher comes in tells the resource manager that this is what we are trying to execute, and our driver is being run on the node manager. Okay, so Spark tells resource manager to create a driver manager on one of the node managers, on the node manager inside the app master or application master. Application master is responsible for the execution of full application on the node managers. Okay, so what exactly is happening here is the here what exactly are we doing? So we are sending our driver application as well as Spark application on the cluster. And what is the benefit? First, even if the client disconnect, even if the user who executed a script disconnect, still the program keeps on running in the background. Okay, just like our MapReduce job. Okay, all of this is happening on top of Yarn. So you as the developer go to Spark and tell that this is the program which we are trying to execute on the Yarn cluster in something called Yarn cluster mode. Okay, and then and is it and then Spark this command Spark submit command will take whatever you are giving it and then push it to the cluster such that Spark application as well as driver application both run inside application master. Alright, is that clear to everyone? Am I making any sense to you? Gaurav, Abhishek, Ashish, Ishwar, Hiren, Jitender, Mahedi? Are we on the same page? Feel free to ask, I can repeat, no problems. So Gaurav's question is the driver, is it running on on one node or on all nodes? It's only running on one node. Okay? It's only running on one of the nodes. Now, in case this node fails, very good question, Gaurav. So if that node goes down, like with any job tracker, if you remember application master's behavior in case of MapReduce, like that, that will be driver application will be moved to another machine, right? Driver application is also resilient in nature. That's a property of Yarn that Yarn makes sure that it tries to execute it on some other node. Alright? So if a node on which if there is an application master or node manager that is shutting down under which the driver application was running, it will start running on somebody else. Alright? Good. Very good set of questions. Feel free to ask questions. I'm completely comfortable in answering or repeating things. No worries. Okay. All right. So you can see that driver application is also communicating with each individual Spark application. And driver application and everybody is actually communicating with resource managers. Now Hiran's question is a little different. So can Spark and driver application run on the same node? Yes, yes. So Spark doesn't have a problem if driver application and Spark application run on the same node. It doesn't have a problem at all. As a matter of fact, in case of standalone, that's what was happening. It's more of a prerogative of Yarn to basically schedule things such that everything runs fine. So if Yarn thinks that running driver application and Spark application on the same node is more efficient than running them on different nodes, then Yarn will make sure that it runs on the same node. Otherwise, if it sees that okay, the Yarn, the driver application is very consuming so much of power from the CPU, therefore it makes sense for other applications to run somewhere else. Okay, great, great. Any questions at this point? Brilliant, brilliant. Very good set of questions. Keep them coming. So Hiran's question is Spark app equivalent to App Master? I would say Spark app is coded by you and runs inside App Master. Okay? So there is always app masters dedicated for various kinds of things. Okay, so there is an app master which is running MapReduce, there is an app master which is running HBase or Tej, and there is an app master which is running your Spark application. Great, brilliant. So is everybody clear about the diagram? Is there any? Okay, let's try to run it. Okay, so in case, all right, I will say launcher. Yeah, this is better. I think this will make more sense. Thank you, Gaurav. So you were on a machine here. You asked Spark to execute your work. And whatever is your driver application is something which contains all the code and is launching piece by piece into the Spark application. Or you can say the driver application is kind of a big plan while Spark application is a single command. Okay? So launcher is the one like you, the way we'll execute the command. We are the launchers and we are launching it on Spark, and Spark is talking to resource manager. How it's talking to the resource manager? By using these environment variables. It has found the name node, it has found the data node, and it has found the yarn cluster IP addresses along with their port numbers. Okay, so that's how Spark is able to figure out where is your name node and where are your data nodes and so on. No? So we give our work to Spark. Spark talks to the config directory here. Okay. Based on the config directory, it will find all the services from Spark. And then Spark will schedule various things on Yarn. Not clear still? So here you can say that there is sort of I can just put it here like this. Here Spark submit is doing the things, and then there is something called U. Okay. All right. All right. So it's you who came with your program, gave it to Spark Summit. Spark Summit talked to the resource manager, and you gave the whole code containing the whole plan. And then resource manager the Spark Summit talked to the resource manager, found out everything, then submitted everything, and it has started running on different nodes. Now, even if these here there is a disconnection after some time, it doesn't matter. The work has been submitted. Okay. Now let's try to run it. Now this time let's try to run it in this manner. Okay. All right. Yeah. Now again, let's go to track the job here. This is our map ready. The yarn job. Okay. Is this the one? Yeah. So here is your output. It has put the data. It has put the results in the output. Okay. It has put the result in the in the logs itself because it's just printing. All right. Were you able to? Okay. Good. All right. Ishwar is saying this is not the case with Storm. All right. That's a different discussion itself. And there is another question from Hiren. The question is, so when I'm submitting a job, what will be the role of driver application? Driver application is the main application which talks to the various nodes and keeps on sending the commands to be done. Let's say the full application is the role of driver application. It keeps on delegating it to the task tracker, collecting the results and summarizing it is the role of driver application. Sounds good to you, Hiren? No? Yes. So it runs inside the app master. Okay. AppMaster is more like a virtual machine which can run anything. Driver application is something which you have written, your code, and that application master picks it up, executes it on the node manager, and whatever are the results are given back to the user. All right. Brilliant. So driver in the application in the Spark is similar to MapReduce driver. Yeah, you can say that. So driver application is running your code the way MapReduce runs. Okay. While AppMaster is part of Yarn, driver application is part of Spark. Okay. All right. I hope everybody is with me. So this is the one which we just executed. And the queue name we have just mentioned as default. We can give any name we want, but before that we'll have to create that queue on the yarn. Are there multiple types of driver application? What is the default driver application? So in this case, the driver application was written by you. Okay. What we did right now is this is what is called as driver application. This one. Okay. This is our driver application. Okay. In this case. Which is essentially your code. Sounds good to everyone? All right. Great. Great. So that this was a bit of an architecture detail of our Spark and various modes. So we discussed first about how to download and get started. What are the various binaries available? Okay. Spark Shell, PySpark, Spark R, and then Spark SQL. Also, there were many binaries. Second is the different modes in which you can run your Spark. If you are not interested in installing the cluster and you want to just get started right away on your desktop, even after you don't have cloud access to the cloud labs, then this can be very useful. Okay, the standalone mode can be very useful to quickly get up and running with Spark. All right. Next is the cluster mode the in which we run our Spark in the cluster mode, whereby all the whereby there are two kinds of cluster mode. One is yarn client, another is yarn cluster. In case of yarn cluster, your driver application is not running on yarn. It's only the individual works are getting done on the yarn. Okay. Now the second is yarn cluster, in which the works are getting done, even the driver application along with everything is also running on yarn. Alright. So those are the things which we discussed today. So standalone mode, yarn client mode, yarn cluster mode. Good? Alright. Any questions before we move on to Python? The video will get uploaded in couple of hours from now. Alright. Okay. Alright, let me just. Alright, so let me just go back a little bit. So yeah, looks like it's not still clear what I tried to explain. Let me try to do it again. Okay. So this is our normal architecture of Spark. There is something called driver and there are something called Spark application. Okay. So driver application contains the full script, as in do this, multiply this data set, join this data set, bring it back, then after bringing that, then do the summarization again. Those kind of things, the full script, full drama is part of the driver application. Now individual player work, as in multiply this data set with 15, or individual work is done by Spark application, while full drama play is done by the driver application. Driver application contains your code. Similar is, and driver application keeps on talking to multiple nodes and telling them what to do. Okay, although the heavy lifting is done by individual nodes, not by driver application, not by driver application, but individual node, still uh, I mean, driver application does only sort of the workflow kind of thing. So driver application contains something called directed acyclic graph. Okay, directed acyclic graph means these are the 10 things on which we are going to execute something. Okay, so directed acyclic graph, as in, let me come back. So here, uh, the difference between client and cluster mode. Before that, I'm trying to describe what does driver application do. Okay, driver application directs each node to do something. Okay, if you think about a big program, if you think about big program, it will look like load some data from various nodes, load some data from HDFS into files, then convert this data into, sum up this data, sum up this data and into a variable called x. Okay, now load some data from RDBMS into RDD. Okay, load some data from HDFS into RDD. Okay, and load some data from RDBMS to RDD. Multiply each record with the sum. Sum as in sum, done in the step number 3. Okay. Okay, so this is what driver application does. While individual node do things like run map, run reduce, and the things which are being directed by driver application. This is the diagram. Now, to get it done on Yarn, Spark applications run inside AppMaster, but where does driver application run? In case driver application is running only on the node on which you are working, then what would happen in case the node which on which you are working goes down? Okay, so the whole process will break. So that's a yarn client mode. Yarn client mode is a little bit faster because driver application is on your node, so you can see what's going on. Okay, the next one is like a background process. Okay, you did a Spark submit, it started running the driver application in the background. You can disconnect at this point, and driver application will continue its work while running on the node manager. No, it's still not clear here. So the work which was earlier being done here has been shifted to the node manager, which means even if this guy disconnects or something happens to it, still it will keep running on the server. So this is wrong. This should be yarn cluster mode. I think this might be confusing some of you. Great, great. All right, so time to move. Before we, if you have any questions, you can ask now. Otherwise, we'll start our discussion on Python. No questions? Great. Great. So it takes a bit of time to understand what's going on. Or do you want me to run a couple of examples in Python and then? Good, very good question, Hiren. Yes, that is something I did not mention. Thank you. All right. So there is another question from Hiren. The question is the driver application can be coded either in Scala, Python, Java, or R. Yes. All right. It can be coded in any of this. All right. Any questions at this point? Very good set of questions. All right. So a simple question. Execution of MapReduce on a cluster. Okay, question to all of you is execution of MapReduce job is more similar to yarn client or yarn cluster. This one or this one. This one is yarn client mode. This one is yarn server mode. Yarn cluster mode. Anybody? Brilliant. Brilliant. Anybody else before I tell the answer? Only Gaurav and Mehdi had said. Any any other answers? All right. Depends on could be either. So let me ask you this. All right. I think a better way would be to have the interactive discussion. All right. Let me ask you this. Okay. So the output of MR job is displayed on screen. True or false? Good. Which one out of yarn client or yarn cluster mode displays results on screen? All right, brilliant. So now let me try to answer. So the output of MapReduce job is displayed on screen. False. The output of MapReduce job actually goes into a file. Okay, because that's a batch kind of mode. Similarly, out of yarn client and yarn cluster, yarn client is the one which displays on the results on the screen. Therefore, in behavior, the yarn cluster mode basically gives output in the background to the uh, file on the server, while yarn client gives you the results on the screen. Okay, it's like how when you submit something to a server, it gets done, it saves the results somewhere on the server. Okay, but if you run something on the local machine, it runs in front of you. Once it's done, it just let us know. Okay, now again coming back to here, that means executing of MapReduce job is more similar to yarn cluster because it's a background job. So we have a very good question from Gaurav. If my driver is in R, so do we need to specify Spark R to execute in cluster mode? No. No matter in whether you are writing in R or anything else, at the end of day, it all get converted into Java code. Okay, so whether R, it becomes Java code. Even Scala, it becomes Java code, and same is with the others. Okay, brilliant. Any other questions? So if my driver is in R, so we need to specify Spark R to execute it. No, we need done. Yeah, we the command line, the bin/bin/spark r, we have to tell like this. We have to tell it yarn cluster. Okay, we have to tell this command line to execute in yarn cluster mode or yarn client mode, or you can say my script like this. Make sense, Gaurav? Yes. So yes, as far as I know about Spark, it tries to convert everything into Java and then get it executed. All right. Good. Good. Can this be a backdrop? As in, I did not get this. Can this be a backdrop? As in, so this happens like internally while compiling Scala, it gets compiled into jar. So it's of course the background job. All right. Yes. Are you with me? Good. Good. I think everybody got it. Ashish, Ishwar, Gaurav, Hiren, Jitendra, Mehdi. Yes, Ashish, you have raised your hand. I did not notice that. All right. Good. So let's start with Python now, and then we will continue our Python discussion tomorrow, and we will also try to finish Scala if the time permits tomorrow. Right? Everybody okay? Brilliant. All right. So the theme of the Python course is little different. It's designed for different audience. All right. So how many of you know Python already? Who all knows Python already? Hiren, Gaurav, Mehdi, Jitender, Ishwar. How many of you know? Okay. So Hiren knows in bits and pieces. Gaurav doesn't know. He sorry. Ishwar knows in bits and pieces. Hiren doesn't know. And Ashish Ranjan doesn't know. All right. So it would make sense to actually learn Python. All right. Mehdi knows a little bit. All right. All right. So good. Then it will make a lot of sense. So why do you use Python? Why do people use Python? Any ideas quickly? All right. For the basically people use Python for the software quality. Yes. Yes. Thank you, Gaurav. Gaurav says that it has rich libraries for research etc and is easy to learn and execute. Yes, exactly. So that is main reason why we use Python. All right. So the main important aspect of Python, why people liked it, because it was very readable, it was very maintainable, and it was object oriented. And when people found it nice, they started building libraries, and it became very, and when people found it nice language in terms of developer productivity, then they worked a lot on that. And that's where the libraries came from. So code size is around one-fifth of that of Java. And personally, when in my Hadoop class, when I was trying to teach Java to the people who have never done programming, it was very difficult for me. Okay, it took more time than I had expected. I was thinking that Java will finish in like 3 hours, but it took me more than 10 hours to finish Java course. That was a complementary course which we did with our Hadoop class. So that time I realized that it's not that simple to learn Java straight away. But with Python, most of the people were able to learn really quickly. Okay. For example, when I show people the code for the first time, hello world, there is outer class with some a public class, and then class name, and then curly brackets, and then you have public static void main, and then all of this. Now, although we are just saying hello world, what are those things for? Okay, so it's little intimidating, it's not very friendly to the newcomers. Same case was with C++ and other languages, where even for doing mundane things, even for doing very small things, you have to write lot of code. All right. So because of those reasons, people started preferring Python over other languages. Also, since Python makes sure that you use indentation to separate one block from another. So if something is in the same block, they have to have the same indentation. Because of that, the code became cleaner. The lesser the symbols in your code, the more readable it is. So it became cleaner and more readable, and that is why people started liking it. On top of it, it is fairly portable. It runs on Windows, Linux, and Mac, and it supports libraries. Okay, it has got probably the richest libraries in terms of various areas. Although library of R as a programming language, library of R is rich when we talk about the data oriented problems. But in Python, there are libraries for all kinds of business problems, or all kinds of problems, such as for website construction. The interface hue you must have seen is written in Django, which is a framework from Python. Similarly, the payment gateway which we use, called Instamozo, is written in Django, which is again Python. Now, numeric programming such as NumPy and SciPy, they are far better and richer libraries when we compare with MATLAB. Now, there is something called Pandas. Pandas is also a very brilliant library and runs really nicely any of the R programs. Okay, so basically, if you want to do anything, probably Python can be a good choice. Okay, now say for example, I was trying to experiment with something like I'm actually working on that. So all the videos which we are recording right now, can they be automatically can we automatically clean them? If there is a silence for more than 5 seconds, it would delete that portion of the video. So those kind of automations are very quick and easily done for you. Okay. So given all these reasons, even the certificate distribution which we do, we have done it in Python, because library to convert anything into PDF was very easy. and there were lots and lots of really good feature readily available, including image manipulation. All right, so probably for almost all kinds of work, Python is a great library. And in case of the data churning, because of NumPy, SciPy, and Pandas, and few more libraries in data churning, the the Python has become the main choice of any of the data architects, data scientists, and any other machine learning researcher. Okay, because when a programmer starts to work, if there are if if there is a lot of things to code, then subconsciously the programmer develops an inertia to work and the work get delayed. And that is why a lot of programmers have abandoned the other languages to come onto Python. Okay, basically act of programming should be pleasure than the labor. Okay, and Python has been successful in doing that. All right, although for example, although I have been working for around 10 years in Java, but still if somebody asks me to quickly code something, I have started doing that in Python, and I have hardly learned Python for around 2 years. Two, I mean, you can say 3 years. Yeah. All right, so personally, I mean, the reason is that it takes less amount of effort and learning to learn Python. All right, is it is a scripting language, anyone? All right, it is a scripting language. All right, it's a scripting, it's a general purpose programming language that blends with procedural, functional, and object oriented programming. Okay, so it doesn't impose unnecessary constructs of object oriented programming. It is functional as well as procedural. Procedural as in from top to down, step by step. Functional as in it has functions and modules, and it also provides the other function oriented constructs. We will get into that. And it's a general purpose programming language. All right. All right, good, good. So that's pretty much for today. We will start from here. The execution speed of Python is slower, as in as compared to C++, but there are compilers which compile it to run at least 100 times faster, such as PyPy. PyPy compiles the same program to run little faster. All right, there are lots of companies who are using it, and yeah, you can have a look. There are lots and lots of companies are using it, and all right, all right, good. All right, thank you very much. Have a good day, and yeah, we'll see you tomorrow. Thank you, Hiren. Thank you, Gaurav. All right, thank you, Asif. Thank you, Jitender. Thank you, Mehdi. Yes, same time tomorrow. Same link. All right, link will remain same. Bye bye.